Now here's where you actually create the model. So it looks like what you're doing here is you're converting words into vectors of length 16. And then these vectors of length 16 are being used to determine the meaning of the review, whether it's positive or negative. So I ran these two, I guess I ran these before. If you run these, it's going to give you the shape. No, these are the parameters. So what this 16,016, well, 160,016. So on each of the 10,000 words, it's training 16 weights because it needs those weights to convert each word into a vector. All right. But because the vector is of size 16. And then here, down here is where you take the vector and you weight it and you get a total review. All right, and here it explains the layers. Now you've seen this before, that we need to, when you train the network, you need to have some idea of how well it's doing so you can nudge it in the right direction. And we use cross entropy before. If you have two classes, then you compare your result, which is going to be some number, with the actual vector. The actual vector is going to be either 1 or a 0, depending on whether the review is positive or negative. So let's go ahead and do this. And then we've seen this also before. Epochs is the number of time it runs through the data. Here we're specifying the training set and the validation set and the number of epochs. And this will take a while, so I guess I will pause. All right, we're finished here. Let's see what's happening with the loss and the binary accuracy. So the loss goes down, which is good, and the accuracy goes up. Looks like we got up to 91% accuracy. Oh, all right, so here this was the on the training set. On the validation set, it stayed about 87. All right. So the reason that the training set does better than the validation set is this overfitting. It's adapting to particular characteristics of the training set. I think I've talked about this before, but this is typical. What happens is that the training accuracy keeps on going up, 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 but the validation accuracy kind of peaks. It kind of flattens out beforehand. And we'll see how to represent this progress shortly. So now to get an independent evaluation of how good the model is doing, we evaluate on the test set. So here we're doing again the same thing that we did up before, but here we're just evaluating the result on the test set. And you can see the accuracy here is about the same as what you got on the validation set, which is good. Now this part's important because I think it is good to graph what's happening while you're training your model. So when you do your model fit up here, that was this training process here, it also records what's going on. This history equals, right? This is the recording of what happens when you do your model fit. All right. So so you can query this history and find out different characteristics of the training. So this history object here that was created during the training, it has an attribute called history. So that's why they put history point history. This is an attribute of this variable history up here. I don't really like the way they do this, that they call the variable the same that they call the attribute, but that's what they do. This history refers to the variable, to the object name, which the record of what happened during the model. And that history dot history is the history attribute of that object. All right, so let's see what this says. So these are all the things that are saved in this history, and in the history of this record that's saved here. So this is going to show these things as the model progresses, and we can graph these. All right, so here we have the, see here we're pulling out these 4 attributes. We could see history dict has 4 attributes. And then this is the number of epochs. Okay. And then here we can plot the loss for training and for validation. All right, so this is going to give us a loss graph. And these are usually the 2 graphs that you show. You can see the blue dots is for training. You can kind of key that to what's happening up here. This plot is the command for plotting. And here we have BO, that's the blue dots here. And you can see that that's labeled training loss. Let me explain this in a little more detail. All right. PLT.plot. PLT is because it's from the matplotlib routine, and plot is the command. When you do a plotting routine, you have the x vector and the y vector. So this is the x-axis values, and this is the y-axis values. Right? You should have one loss for each epoch because the loss varies over epoch. All right, so this is the x values, y values. This is the type of line. It's blue and it has circular markers, and this is the label that's attached to that data. All right. Similarly, this is for the validation loss, the epochs. That's the x values, y values. This is just a blue line. Okay, title and x labels. Okay. So we'll be using this for other situations as well. So it's important to understand that when you run your model fit, I think it's up here. When you run your model fit, make sure that you set that equal to some object, which they typically call history. And then you can query the history attribute of that history. And you can plot data from that to see the progress of your model. All right, so that's this one. Now we can do the same thing with the accuracy. So that was lost. This is accuracy. And here you can see the training accuracy flattens out, but the validation accuracy, the training accuracy keeps going up, up, up. The validation accuracy flattens out. This is overfitting. You should really stop training before this gets above here, because your training process has gone a little bit too far. All right, so you can read this. Training loss decreases, training accuracy increases, and so here you've got this here. Okay. And this shows how to export your data and use it on, export your model and use it on other data. So we do this. And not sure how long this is going to take, so I guess I'll pause. No, it looks like it's going to be pretty close. Okay, so it looks like it gave about the same accuracy. Okay. So if we look at these reviews here, so this 61% means that it's probably a good review. It's close to 1. 1 means good, and 0 means bad. So you can see here this one has a higher rating than this one. And you can see it's just keying in on this one word, great, terrible. Okay. All right, now what we did above was we looked at movie reviews and decided whether they were positive or negative. So in this exercise, it's very similar, except what we're going to be looking at is questions that are posted on this site Stack Overflow, and you want to decide which language, which computer language the question refers to. So above we only had 2 classes, positive and negative. Here we're going to have 4 classes. Okay. And you want to predict which class the question belongs to. Now if it has the word Python in there, it's probably about Python, but sometimes the question may not have the actual language mentioned. Okay, so let's see what we have here. Right. So we have some, in this case we have not just one class, we have 4 classes. Remember we had a positive and negative before, now we have 4 classes. Okay, I see. So here, in order for this test, they remove these words so that you have to guess what programming language it's talking about from the context. So this tells you what you need to do. All right, so what you do is you simply copy this notebook and you make these changes one by one. Right? And where you're accommodating not just 2 classes, but several classes. Okay. So see if you can make those changes. So instead of binary, it's multi-class. Okay. So try to make those changes to adapt your model to do this multi-class classification. Okay, that's it.